In this lesson, you will learn the concept of inheritance in object-oriented programming. Now, let's say that you're tasked to create a software system which represents a specific zoo called the cyber zoo. The zoo contains many animals. This zoo has one animal of each type, and they all have names. Elephant is called Ela, giraffe is named Jiffy, lion is named Lolo, chimpanzee is named Chimpy, and a wolf is named Holo. Although currently they have one animal of each type, in the future they may get multiple animals of the same type. And now your job is to represent each animal in your code. And when the user clicks on a specific animal, you should display all the details on that animal, which includes the name, age, where they came from. And when the user clicks on Make It Talk button, you should display how they talk. With the given information, we are all set to define our class. And here is our first class, which is a lion template. The lion class has three instance variables. The first one holds the name, the second one holds the age of the lion, and the third one holds the value of which continent this lion came from. And then we have a constructor which constructs an instance of the lion by taking all the three values. And then we have a speak method. By calling the speak method, you get to know how the lion speaks. And now we will write our zoo class, which instantiates the specific lion by sending in all the required values through the constructor. So now if you compile both the classes, zoo and lion, and if you run the zoo class, you will see roar on the console. On the same principles, here is the elephant class. It has the exact same set of variables as that of lion. However, speak method is different because the elephant trumpets. Now, what about the chimpanzee? Well, as far as the variables are concerned, it's exactly the same as that of elephant and lion, except the speak method. Well, chimpanzee has its own secret language. Well, with the wolf class, the wolf howls, and that's how the speak method is different here. And the last one is giraffe. And did you know that giraffes hum silently? When you look into these animal classes that we created, they all have identical variables. That is the name, age, where they came from. However, their speak method is different. This is the kind of scenario where you should use inheritance technique. So instead of repeating the same set of variables in all the classes, you can put those variables in a top level animal class and make all the classes extend this animal class. This is how you would rearrange the classes for this to work. First, create a new class called animal and move the three variables to the animal class and remove the private modifier for the variables. If you keep the private modifiers, then those variables will not be inherited by its children. Then add the extends keyword after the class name in the lion class and give the name animal after the extends keyword. To make things interesting, add the name variable to your println statement. Did you guess which name variable it is using in this line? You guessed it right. It is coming from the animal class, and the lion inherited the name variable because it extended the animal class. Now if you run your zoo class, you will see the below result. In the UML class diagram, you would represent the relationship this way. The animal is called the parent class and lion is called the child class. Notice how the variables are represented in the animal class. The negative sign is removed as this is no longer private. Based on the same principles, the other four classes can be simplified as shown here. UML diagram, which shows the relationship of all the classes, looks like this. Animal class is also called the superclass, and all the other children are also called subclasses. Now, if you revise your zoo class, compile and run it as shown here, you would see the results as shown in the console screen. Inheritance is also called an is a relationship. What is the meaning of that? What it means is every child instance is a child for sure. However, it is also its parent. Let us take the lion class as an example. When you instantiate the lion class, the object that is created is of type lion. However, the object is also of type animal because animal class is the superclass of the lion class. So the same is true with every other class that we have here. So an elephant object is of type elephant, but it's also of type animal, etc.